Okay, so today we're going to talk about conductor fill and conduits. And the reason why you do this is to help dissipate heat, protect your conductors, and to facilitate installation and demolition of your electrical system. Basically, there are two times to do this. One, when you have the same size conductors in a raceway. The other time is when the conductors are of different sizes in the raceway. When there are the same size conductors in a raceway, you would turn to Annex C and you would find the table of contents for the type of conduit that you're talking about or that is in question. You can see here that there are all these are several different types of conduits that the electrician uses, and they're organized by C.1, C.1a, C.2, C.2a, and so forth. When you're doing these calculations, you have to note and be aware that the insulation type is necessary, and you have to make sure that you're on the proper table depending on what the question is asking you. The first table is conductors and fixture wires. The other table is for compact conductors. So be aware of which table you're on. Always turn to the table of contents though for the annex and find the page number for the conduit in question. Here's an example. How many number 12 THHW conductors can fit in 1/2 inch EMT? First thing that you would do is turn to the table of contents in the annex. You'd find EMT, and that would put you at table C.1. Here's C.1, EMT, electrical metallic tubing. You'd find the insulation type in the left-hand column here. THHW is here. And the size of conductors that we're talking about is number 12. So how many of these number 12 THHW conductors can fit in 1/2 inch EMT? Here's 1/2 inch column, and you find that 4 number 12 THHW conductors can fit in 1/2 inch EMT. So all these numbers in this table represent the number of conductors that could fit in EMT at these various sizes. Example 2. How many number 14 THW conductors can fit in 3/4 inch EMT? Again, turn to Annex Table of Contents. C.1 is EMT, electrical metallic tubing. Find the insulation type, which is THW. In our case, it's number 14. And the question is, how many of number 14 THW can fit in 3/4 inch EMT? Here's the 3/4 column, and the intersection of the row and the column will give you your quantity of conductors. 10 in this case is the answer. Example 3. How many number 8 THWN conductors can fit in 1 inch IMC, intermediate metal conduit? Well, IMC in the table of contents is located at table C4, or C.4. Here, just to make sure that you're there, this is C.4 right here. And you're looking for type THWN number 8. Here's THWN number 8, and we're looking to fit those in 1 inch IMC, and our answer 10. The intersection of the column and row is 10. Now there's different size conductors in our raceway. You would use the following tables: Table 1, Table 4, and Table 5, all in Chapter 9. Table 1 in Chapter 9 represents the percent of cross-sectional area of your conduit when you have one conductor, two conductors, or over two conductors in the raceway. So these are your percentages here. When there's one conductor in a raceway, you fill it to 51%. When there's over two, you fill it to 40%. Table 4 will give you those percentages, and here are those percentages explained. So here's your over two conductors. You could fill that cross-sectional area to 40%, 31%, and 53%. In this case, this is EMT, this is ENT, this is FMC. So be careful to note what conduit you're on. Table 5 will show your percent or your total area, cross-sectional area of your conductors. So this is the column we want to work with in Table 5 is your square inches of your conductors. And you can see here that it does matter what type of insulation you're talking about. So make sure that you're on the proper type of insulation. Here are some examples. What is the minimum size EMT conduit that could contain two number 12 THHW conductors and two number 10 THW conductors? The first step is you'd go to Table 5 to get the amount of square inches that are occupied by all your conductors. In our case, we have two number 12s. We find THHW, and number 12 is way up here. They occupy each 0.0181 square inches. You multiply that by 2 and you get a number. And you also have two number 10s, each occupying 0.0243 square inches. You multiply those two together, since there are two, you get a number and you add them. That's your total amount of square inches occupied by all the conductors in the raceway. Now you use Table 4, Step 2, to determine the size raceway that those conductors can occupy. Well, the total quantity was 0.0848, and you are looking for a size one larger than that. You're looking for a size that's larger than this total here. So you're looking for, your question is EMT. Here's the EMT table, and you're looking for a number that's larger than 0.0848. The next larger number is 0.122 square inches. 0.122 square inches corresponds to half-inch EMT. Answer is half-inch EMT. Example 2. What is the minimum size RMC conduit that could contain 4 number 12 THHN conductors and 5 number 8 THWN conductors? Again, step 1 would be to determine the total amount occupied of all the conductors. You have 4 number 12s, THHN. Number 12s occupy 0.0133. You multiply that by 4, and you do the same with number 8 conduit, or conductor, THWN. Number 8 occupies 0.0366. You multiply that by 5, you get an addition here, and you get 0.236. And you're looking for the largest conductor, the largest conduit of RMC. The larger conductor that is above 0.2362 is number 0.355, and that corresponds to 1-inch RMC.